of column in your building. Okay? Anyway, we can, from structure analysis, we didn't cover this in structure analysis course, but software can tell you what is the torsion on your building, beam or column. So if your torsion value smaller than or equal this term, okay, go ahead and neglect the effect of torsion. It's nothing. You can neglect it. But if not, no. We need to design our stirrups to support or to resist your shear and your torsion. Okay, go ahead. What this value is? Phi lambda square root of FC prime ACB squared PCB. It's only just parameters from ACI. Phi for shear or torsion 0.75, that's right. Lambda depend on what type of concrete. We are working on normal weight concrete. So your lambda equal 1. FC prime, characteristic strength of concrete. What is the compressive strength of your concrete? ACB and PCB, area and perimeter of your cross section. H, here is your cross section of beam, column, whatever. B time H. So ACB, area of your cross section. PCB, perimeter of your cross section. H plus B times 2. So please make a comparison between your structure analysis results for torsion with this value. If you found this one smaller than this term, okay, neglect the effect of torsion and forget it. If not, no, we need to consider it. First system. Any question? Any question? By the way, torsion not included in the FE exam. Second one, or second step, we need to be sure that your cross section as a concrete cross section is enough to support this torsion. So we need to check that concrete section is large enough to support shear and torsion. If you go back to your shear, effect, we have contribution from concrete. For torsion, we have contribution from concrete. So we need to add both of them, contribution for shear, contribution for torsion. Both of them must be smaller than or equal this value, according to ACI. So here is the shear force from structure analysis. Here is the torsion from structure analysis, divided by B web depth plus this one time BH divided by 1.7 AOH squared. All of this stuff under square root, smaller than or equal this term. Actually, we have to some new parameters like BH. We have here PCB, but this one is BH. This one is AOH. What's this value? Okay, here is your cross section. That's right. This distance is H. The total distance here is B. Do you agree? Please come to the center line of your stirrups. Center line. Center line of stirrups. Center line. Center line. So PH, this term is the perimeter of this center line. So what should I do? First, what will be your x1 and y1? x1 this distance, y1 this distance. What do you think? x1 will be the total width minus this cover plus this cover plus one diameter of your stirrup. Do you agree? Yeah. Here is your stirrup. We have diameter of your stirrup, and here is the other leg of your stirrup. And here is your cross section. Here is your cross section. This value is your cover. This value is your cover of concrete. We are looking for distance between this center line and this center line. So we need to subtract another half diameter and another half diameter. So your distance x1 will be the total distance b minus one cover minus another cover minus half diameter minus half diameter. So your x1 equal b minus 2 cover and the stirrup leg diameter. You got it? The same calculation also for y1 will be the total thickness h minus the same 2 cover plus stirrup leg diameter. Once you get your x1 and y1, that's all. AOH, this value, equal x1 times y1. This term not used here, but later. We have another term AO equal 0.85 from this term. Anyway, BH, this term equal the parameter for x1 and y1 equal this value.
Dr.
Yeah.
Emmett, for the diameter for number 3, we use 3/8.
Yeah, number 3, go ahead and figure out what is your diameter. Your area 0.11 inches square, but I'm looking for what is the diameter. Go back to your table and you will find for number 3 you have a value for diameter. Okay. Once you calculated this value, go ahead and calculate this value. This one must be smaller than this one to say, hey, my cross section is enough. If not, we need to increase this cross section. You have to increase. You have to increase this cross section, maybe increasing your width or increasing your depth. So right now, until now, we are trying to say, hey, torsion is neglected or not. Hey, our cross section is enough or not. If not, you must increase the cross section by increasing your depth, increasing your width, or both of them. Any questions so far? What is the next step? Third step, and the last one. Do you have a question?
Oh no.
No. I never did.
Then go ahead.
Okay.
Go ahead and calculate this term. AT divide S equal this term. Or this term, that's fine. But I don't need to calculate Tn, which is nominal torsion resistance. Forget it. AT over S equal T ultimate from structure analysis divided by 2 phi, 0.75 for shear and torsion. A naught. Anybody remember what is the value of A naught? Yeah? A naught 0.85 from AOH, and the AOH is this area x1 times y1. F yield, what is the type of steel? what is the yielding stress of steel for stirrups? Cotan theta. Your angle theta in shear or torsion will be 45 degrees. So cotan is the inverse of tan. So I can calculate AT over S. AT over S is the area of one leg of a stirrup required to resist torsion only. Hey, do you remember what is the difference between AV and AT right now? AV is the area of two legs or all of legs of your stirrup. AT is the area of one leg only. So, if you would like to get the total area required to resist shear and torsion, here is your value from shear and here is your value from torsion time 2. Why time 2? Because this one only for one leg. To get your both legs, you have to multiply by 2.
To get for 4 legs, you multiply times 4.
Good question.
8 legs.
Standard said no.
Yeah.
No. If you have stirrup with 4 legs, all of these legs will support your shear. Only outer legs will support your torsion. The standard says this. If you have many legs for your stirrup, 5, 6, 100, all of these legs will support your shear. So area V equal 1, 2, 3, 4 time area of one leg. If you are talking about torsion, no, wait. Area T equal 2 time area of one leg. Whatever, how many legs do you have? So all the time, this number will be T, will be 2, regardless how many legs do you have.
And then, I don't know if we're gonna do any problems like this, but the distance between the 2 outer legs is our x1.
Yes, yes, yes.